Total, how many of you were there in your civil class? Only four of you have joined. Four, yeah, 1, 2, 3, 4, 5. Yeah, fifth is me. Four of you have joined. Marak, Nurrahman, Bangam, okay, Jalaluddin. Welcome, Jalaluddin. Jalaluddin SK. Okay, Tana, Gaptok. Tana Gaptok, I am seeing you for the first time. You haven't been in my class earlier, right? Can you hear me, Tana? Okay, I think seven, six or seven of you are already here. Okay, today what we'll do, we'll start with a topic called turning operation. Okay, uh, basically turning operation is what? Suppose you have a um, round cylindrical metal rod, and you want to finish it means you want to remove some excess material, or you might to decrease the you want to decrease the diameter of the rod. Okay, uh, then in those cases what you will do is you will use your lathe machine and you will do the mm, turning operation. Okay, turning operation is basically used for chipping off the excess material from a cylindrical face. Okay, or you can say that decrease the diameter of a cylindrical face of a cylindrical rod, right? Just tell me whether mm, you can see my screen or not. Can you guys see my screen? Is my screen visible? Okay. Okay. This is a typical definition that I have given here of turning. Okay. So turning is a form of machining, a material removal process. So basically, it's a material removal process that I have already told you that, right? If you have a cylindrical rod, if you want to remove the excess material, or if you want to decrease the diameter of a rod, okay, then you will use the turning process, or any cylindrical object for that matter. Okay, it is done in a turning machine, or you can do it in the lathe machine also that you have in your workshop. uh, Today I will show you a video of a parts of turning machine if you have not seen the turning machine yet. Okay, a 3D video I have gathered from the YouTube. I'll show it to you. Okay, so that you have a better idea. So turning is a form of machining, a material removal process, which is used to create rotational parts by cutting away unwanted material. Okay, the turning process requires a turning machine or lathe machine. Then in the lathe machine you will be needing a workpiece. Workpiece will be your object from which you will be wanting to remove the materials from. Then fixture, where you will adjust or you will fix the workpiece. Then the cutting tool, okay, through which you will remove the excess material. Okay, the workpiece is a pre-shaped material that is secured to the fixture, which itself is attached to the turning machine or the lathe machine and allowed to rotate at high speeds. The cutter is typically a single point cutting tool. I think you already know what is SPC, single point cutting tool. or multi-point cutting tools are also there. That is also secured in the machine. Although some operations make use of multi-point tools, the cutting tool fit into. Okay, Nihar Deka has joined the class. Okay, the cutting tool feed fits into the rotating workpiece. That means gradually what will happen, the cutting tool will be fed to the rotating workpiece and the excess material will chip off from there. I will show you the video, then you will properly understand it. Okay, and the cutting tool fits into the rotating workpiece and cuts away the material in the form of small chips to create the desired shape. The turning is used to produce rotational and typically axisymmetric. Axisymmetric means the operation after the operation, the object will be symmetrical axially. Okay, around the axis of the object, it will be symmetric in both the sides. Okay, around the axis. So typically, it is this turning process is used for axisymmetric parts that have many features. It can be used for holes, also grooves, also threads. What is groups? I think threads you already understood. Tapers also I think you can understand what is tapers. Grooves also you will understand, but anyway I will show you how grooves and tapers are done with of various diameters. Okay, and even contour surface. Contour surfaces can also be made. Okay, I'll see. I'll check out whether I can show you some video of contour surfaces also. Then parts that are fabricated completely through turning often include components that are used in limited quantities. Perhaps for prototypes such as custom designed shaft and fasteners, turning is also commonly used in secondary process to add or refine features on part that were manufactured using different processes. Due to the high tolerance and surface finish that turning can offer, it is ideal for adding precision rotational features to a part whose basic shape has already been formed. Okay. Uh, if you are, I think my screen is visible to all of you. So let's see. First, first let me show you. First, let me show you the video on lathe machine, so that uh, while uh, while I describe, so that you will understand what they are saying in the other videos. Okay, just take a look at the video. Okay. Okay, this particular operation that it is shown here is your turning operation. Okay, this is your workpiece which has a greater dia. Okay, after you can see that after turning operation is done, you can see here the diameter of the cylindrical rod or the metal object has been reduced, or the workpiece has been reduced. Okay, so if you want to reduce the diameter of a workpiece according to your specification, this cylindrical object, okay, you can use turning operation. Okay, just complete the video. Okay, I think you got a basic idea of the lathe machine. Then let's see about turning operation. Okay, turning operation in the lathe machine. Already in the video you have seen the turning operation also, but anyway, I have another video for you. Very short video, just go through it. Okay, this particular operation that is shown in the video is your grouping operation. You can see these are the groups. Okay, these are the groups that has been made. Okay, so in between, see, instead of turning the entire length, if we make groups in between, this is called your grouping operation. Okay, then you can do another type of turning operation also, which is known as taper turning. Suppose if you want to do a angle, mm, if you want to do an angle in the turning operation, suppose you need a conical shape in the cylinder. Okay, little bit of conical shape. Then in those scenarios, what you do is taper turning. Okay, let's see how taper turning is done. Okay, these are the few videos where you have seen uh, the different parts of your a basic idea of your lathe machine. Okay, and you have seen how turning process is done, including taper turning also. Okay, so we will go into the details of turning now in our class. Okay, so we got an basic idea what is turning, how it is done. Okay, I think my screen is visible to all of you, right? Okay, so first is tooling. The tooling that is required for turning is typically a sharp single point cutting tool that it has been mentioned in the video that you have seen also right now. Tooling that is required for turning is typically a sharp single point cutting tool. Okay, single point cutting tool means if the cutting tool and the workpiece is touching each other at a single point, then it will be a single point cutting tool. Okay, single point cutting tool that is either a single piece of metal or a long rectangular tool shank with a sharp insert attached to the end. These inserts can vary in size and shape but are typically a square, triangle, or diamond shape piece. These cutting tools are inserted into the turret or a tool holder and feed into the rotating workpiece to cut away the material. These single point cutting tools are available in variety of shapes that allow for the formation of different features. Some common types of tools are as follows. You can see these are a few styles or few types of cutting tools. That is style A, B, C, D, E, etc. A is like 0 degree. It has 0 degree lead angle turning tool, and B is 15 degree lead angle turning tool. C is 0 degree square nose tool. Likewise, you can go through it by yourself. Okay. The above tools are often specified as being right or left-handed, which indicates in which direction which direction they move along the workpiece while making a cut. Okay, as described as described in the previous section, uh, live tooling can also live tooling can also be used for turning, which includes the use of mills, drills, reamers, and taps. These are cylindrical multi-point cutting tools that have sharp teeth spaced around the exterior. The space between the teeth are called floats and allow the material chips to remove away from the workpiece. The teeth may be straight along the side of the cutter but are commonly arranged in helix The helix angle reduces the load on the teeth by distributing the forces. Also, the number of teeth on the cutter varies. A large number of teeth will provide a better surface finish. The cutter teeth cover only a portion of the tool, while the remaining length is a smooth surface called shank. The shank is the section of the cutter that is secured inside the tool holder. All cutting tools that are used in turning can be found in a variety of materials, which will determine the tool's properties and workpiece material for which it is the best suited. These properties include tools hardness, toughness, resistance to wear. The most common tool material that are in use are as follows: that is high-speed steel, carbide, carbon steel, cobalt high-speed steel. Okay, this high-speed steel and carbon steel. These two I think you can see in your workshop also. Okay, the material of tool is chosen based upon number of factors, including the material of the workpiece, cost, and tool life. The tool life is an important characteristic that is considered when selecting a tool, as it greatly affects the manufacturing cost. A short tool life will not only require additional tool to be purchased, but will also require time to change the tool each time it is too worn. Okay. Then materials. In turning, the raw form of the material is a piece of stock from which the workpieces are cut. This stock is available in a variety of shapes, such as solid cylindrical bars, hollow tubes, custom extrusion, or existing parts such as castings or forging are also sometimes used. These are few examples, that is a round bar, round tube that is hollow, then custom extrusions. Okay. Turning can be performed on variety of materials, includes most metals, plastics. Common materials that are used in turning includes aluminum, brass, magnesium, nickel, steel, thermoset plastic, titanium, zinc. Okay. When selecting a material, several factors must be considered, including the cost, strength, resistance to wear, and machinability. The machinability of the materials is difficult to quantify, but can be said to possess the following characteristics. Okay, the results in a good surface finish. This machinability is good, then it results in good surface finish, promotes long tool life, requires low force and power to turn, then provide easy collection of chips. Okay, now what are these chips? In the video you might have noticed the excess material that you have removed, okay, that falls from the workpiece. Okay, those are the small chips, okay, that you have to collect after your machining is complete. You have to collect all these chips and dispose it off. Okay, then mm, possible defects. Most defects in the turning are inaccuracies in a feature's dimension or surface roughness. There are several possible causes of these defects, which include following, like incorrect cutting parameters. If the cutting parameters uh, such as the feed rate, okay, at which rate the tool has been fed to the workpiece, okay, spindle speed or the depth of the cut are too high, the surface of the workpiece will be rougher than the desired and may contain scratch marks or even burn marks. Okay. Also, a large depth of cut may result in vibration of the tool, cause inaccuracies in the cut. Okay. Dull cutting tool. As a tool is used, the sharp edge will wear down and become dull. A dull tool is less capable of making precision cuts. Okay, unsecured workpiece. If the workpiece is not secured is securely clamped in the fixture, the friction of turning may cause it to shift and alter the desired cuts. Okay, so these are few mm, defects that might possibly occur during your turning operation. Okay, so this much for today. If you have any doubt, we'll continue with your doubt. Then we'll take your attendance. Okay. I think after that you will be having one more class, that is from your practical class of manufacturing process. Right.